NASA's James Webb Telescope, that could spot extraterrestrial life, has completed a critical series of tests in anticipation of its launch in early summer 2019. The $8.8 billion (£6.5 billion) telescope has been successfully tested in a giant vacuum chamber at the Johnson Space Center, proving it will function in deep space. Engineers are now confident it will be able to capture starlight in focus and track astronomical targets, describing the completion of tests as a significant milestone. The James Webb Telescope has been described as a time machine that could help unravel the secrets of our universe. The telescope will be used to look back to the first galaxies born in the early universe more than 13.5 billion years ago and observe the sources of stars, exoplanets, and even the moons and planets of our solar system. When it is launched in 2019, it will be the world's biggest and most powerful telescope, capable of peering back 200 million years after the Big Bang. The telescope went through 100 days of cryogenic testing, where temperatures dipped hundreds of degrees below the freezing point to ensure it functioned in extreme cold. The successful completion of this test represents a very significant milestone for JWST, said Bill Ochs, the telescope project manager. It verified the alignment of the telescope to the science instruments, the image quality of the telescope, as well as confirming the thermal performance of the telescope, he said, writes CBS News. We now have verified that NASA and its partners have an outstanding telescope and a spectacular set of science instruments, he said. To detect infrared light from faraway objects, the telescope must be kept very cold, according to NASA. The James Webb Telescope and most of its instruments have an operating temperature of roughly 40 Kelvin, about -387 Fahrenheit, -233 Celsius. But the mid-infrared instrument, MIRI, must be kept even colder. This instrument uses a cryocooler to keep it below 7 Kelvin, or -447 degrees Fahrenheit, -266 degrees Celsius. During additional tests last year, the 18 gold primary mirror segments were tested as well, to ensure they act as a single mirror. The test even managed to continue as Hurricane Harvey battered the Texas coast. Inside the chamber, the team monitored the telescope using thermal sensors and specialized cameras to track the temperature and the physical position as each component moved. After 15 years of planning, chamber refurbishment, hundreds of hours of risk reduction testing, the dedication of more than 100 individuals through more than 90 days of testing, and surviving Hurricane Harvey, the Otis cryogenic test has been an outstanding success, said Dr. Ochs. The engineers began cooling the chamber on July 20 after removing the air.The process that took roughly 30 days. Then the telescope remained in a cryo-stable state for another 30 days. The team began to warm the chamber back up on September 27 before pumping air back in. Then, on November 18, they unsealed the door. With an integrated team from all corners of the country, we were able to create deep space in our chamber and confirm that Webb can perform flawlessly as it observes the coldest corners of the universe, said Jonathan Homan, project manager for Webb's cryogenic testing at Johnson. I expect Webb to be successful as it journeys to Lagrange point 2 after launch and explores the origins of solar systems, galaxies, and has the chance to change our understanding of our universe.